Okay, we finish at around this point. I talk about frontal lobe. Frontal lobe is usually for higher cognitive function, like paying attention, memory, and also other stuff. But it also has this motor cortex. It also controls our movement. And then parietal lobe, it has a somatosensory cortex. It controls our senses. So whatever we touch or we feel, then this part of the brain will process the sensory signal. And also we have the speech center here. Is this for us this is called Broca's area. Broca's area is for us to generate the speech. And this speech area is called Wernicke area. It is for us to understand the language. And then visual area, I already told you that the skateboard accident from one of my students. And then the auditory cortex, yes, since it is right next to the ear, it is for hearing and processing the sound. So this is a very famous clinical case. This guy is called Phineas Gage. So he used to be a railroad foreman. He used to be a railroad foreman and a responsible guy, mild-tempered, well-mannered. That's why he is a foreman. And he is using this steel rod and to try to push a dynamite into the ground. But accident happened. Dynamite explode. And when he is doing this, the steel rod actually shoot up because it explodes. As it shoot up, it goes through his face and behind his left eye, and then it goes through the prefrontal cortex. So what happened is that he miraculously was conscious. So what he did is that he was holding the rod, left eye here. He was holding the rod like this. And then walk himself to see a doctor. Of course, when doctors see that, he was extremely scared because he has never seen anything like this, and he was not ready to help him. So he was transferred to a bigger hospital, and then they helped him to patch up his wound. But something happened interestingly after the accident is that his personality completely changed. So originally he was a mild-mannered, responsible guy. After the accident, he became very violent, extremely. He cursed. People said that he cursed worse than sailor. He is very volatile, and also. Basically, his personality changed completely, like to a different person. Because of that, the railroad company can no longer hire him as a foreman. And in order to make a living, what he ended up doing is to travel with the circus. And this is the picture that he took with the circus. So he kept the steel rod, and then he showed it to people, his accident. And his hair can actually lift up and to show people what happened. The hole here, that's actually the bone is actually removed. There's no bone, so people can see the palpation from there. Then he traveled the circus and to show people his accident. And after I told my student about this. One of my anatomy students actually came up and told me her personal story. She was from Mexico, and then she told me that her family has a farm, and then I don't remember either his father or his uncle ride a horse on the farm, on his farm, and then on her farm, and then her father has an accident, and her father fell off from the horse, and then his forehead landed on the ground, so it completely shattered this frontal bone. We call it frontal bone here. Frontal bone is broken into pieces. Some of the frontal bone actually cut into the prefrontal cortex. So his either uncle or father has a prefrontal cortex damage. And she told me that the accident also changed this person's personality, and it matches what I described in this case of Phineas Gage. So it is also being verified by one of my anatomy students, a personal experience as well. Now the cerebral cortex. As I told you, the cerebral cortex, in the frontal lobe, they are the last area to mature. Why is that? Because it involves a higher cognitive function, like the decision making, and it is mature not until in our early 20s, around 21, 22. Coincidentally, 21, 22 is the age that we graduated from undergrad, from university, we got a bachelor degree, and coincidentally, it is also the legal age for drinking. It says that it explains why a young adult they like to make a risky decision by teenager or young adult, because the cerebral cortex in the frontal lobe is not mature yet. So after they are mature, then they will become adult like most of us here. And the legal age of drinking, why is that? Because I told you in today's class, whenever we drink either beer, wine, whatever, alcohol, then it will kill lots of neurons. If before the maturation of the cerebral cortex in our frontal lobe, then we already kill lots of neurons. That means if the teenager or the people who are in university, they start to drink underage, and then they kill lots of neurons. Let's say if they kill the neuron in the cerebral cortex of the frontal lobe, what will happen is that they can, after you kill the neuron, they cannot regrow. So even though when they reach 21, 22 years old, when they are mature, that means when they are mature, when your brain stops growing, that means the cerebral cortex is not completely mature. That person will, even though that person become an adult, he will still make risky decisions, because the cerebral cortex is not completely developed, and then he already killed lots of neurons, so it prevents the cerebral cortex from fully developed, fully mature. Then that person, even as an adult, can still make risky decisions. Neuroplasticity. Why do we give you this picture? The truth is, we heard about a rumor, and we heard about saying that, okay, young kids, they can learn language better. Is this true? When we were young, until around 12 years old, we should expose our kids to a lot of social environment so that they learn how to express their feeling through a verbal communication. In other words, you should not let your kids to use a smartphone or tablet or video games when they are too young, because you want them to learn to verbalize their feeling, to learn the verbal communication when they are young. After they are 12 or 13, then you can start letting them to play all those smartphone or tablet. But does it mean that after 12 we cannot learn other language? It is not true. It just means that it takes a lot more effort to do it, because our brain is plastic. Plastic meaning that our brain can be modified even though we are adult. Even now at our age, most of us here are adult, we can still learn new language, learn new techniques, learn new motor skills. because our brain can be modified. Our brain is plastic. What it shows in this picture is that it is a real clinical example. Someone had a headache, so he went to see a doctor. Doctor cannot find any reason. Then he put the person into a scanner, and this is what they see from the scanner. Half of the brain is not gone. This is the half of the brain. Half of the brain actually shrink so much that it is like it is gone. But the person is almost normal, except complaining of the frequent headache. How does it tell you the neuroplasticity is that even though half of the brain shrink and almost gone, the other half of the brain picks up the function of this shrink half of the brain, the hemisphere. So this hemisphere picks up all the function of the other hemisphere. That's why we call it neuroplasticity or neuroplastic. The brain is plastic because it can learn or acquire the function of the second half of the brain, even though this part of the brain shrank to that small. The possible reason is that somehow the brain it has excess of the CSF, cerebral spinal fluid. Too much pressure is built up inside the brain. Because too much pressure is built up, then it squeezes one hemisphere of the brain into such a small size. And it does not occur in one day. It occurs chronically throughout many years. So the build-up of the pressure takes a long time, and the pressure that pushes the brain into small pieces also takes a long time. So let's talk about other neurological disorder. This is a very famous one, Alzheimer's disease. It is. How many of you have watched the movie The Notebook? Yeah, The Notebook is a very romantic movie. It has it has something to do with Alzheimer's disease. I don't want to give you the spoiler. You should watch it. It's a good movie. So it is characterized by confusion, memory loss, or dementia. So many of the Alzheimer's disease patients do not remember their family member. That hurts their feeling a lot. So if it happened to your family member, your grandparents, so don't take it personally. It is because they are ill. It has something to do with the loss of the neuron in the temporal lobe. In the temporal lobe, yes, we talk about that it has something to do with auditory function. It is for hearing. But some of the neuron there, some part there is something called a hippocampus in the temporal lobe. Hippocampus is a structure in the temporal lobe for consolidating or for consolidation of memory, meaning that hippocampus is responsible for transferring short-term memory into long-term memory. We call it consolidation. So if there's a loss of the temporal lobe, it can affect the memory. Usually, when we are getting old, if we're 65 years old, 12% of the population will have this Alzheimer's disease, and 85 will be 50%. So the keywords here is transduction, sensory transduction, a transducer. Transducer is an electronic equipment that can convert one form of energy into another form. A common transducer is in your cell phone camera. Your cell phone camera is a transducer because it converts the light energy, the photon, into electrical energy, into electrical energy, so that your cell phone can show the image on your cell phone screen. So it says that the stimulus is detected by receptor, and receptor is actually a form of transducer. So the receptor can convert one type of signal into electrical signal. Electrical signal that it is called. This electrical signal is called action potential that we just learned. And this conversion is called sensory transduction. Basically, it's the change of the membrane potential we talk about to generate action potential. The sensory adaptation, meaning that when the same stimulus is repeatedly given to a receptor, then the sensory receptor will become less and less sensitive. The reason is that the purpose of doing the adaptation is to keep the body from continuously reacting to the normal background stimulation. For example, in this room, if I don't speak, if everything is quiet, theoretically you should be able to hear the background noise, which is the air conditioning. You can hear the air venting out from the ceiling. But because the background noise, the venting of the AC from the ceiling is continuous, then our senses, our ear actually adapted to that noise. So if we do not pay attention to it, we will not be able to hear it. So we have to pay attention to it, then we can hear it. So it helps us to, why is it so important? Because we don't want to pay attention. We don't want to pay attention to useless information or useless stimulus, such as the AC noise coming out from the vent. We want to pay attention to the useful stimulus. That means the lecture that I'm giving to you now. We have different types of receptors. So it can group into 5 categories. The first one is called pain receptor. Pain receptor can sense both temperature, heat, and also pressure. Pain and temperature, well, actually, they separate into two. So it can respond to excessive pressure and chemical from damaged tissue. And the thermoreceptor detect heat or cold. And then mechanoreceptor detect mechanical energy, actually the physical movement. Pain receptor has a different name. It is called nociceptor. Noci means noxious. 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 Meaning that this receptor detects a harmful stimulus. Chemoreceptor detect the chemical changes inside or outside of the body. For example, if we have a low blood glucose level, then there are chemoreceptor in our body, in the brain actually, in the hypothalamus, that can detect the low glucose level. Electromagnetic receptor, there are basically only one type. It is the photoreceptor in our eyes. Because there's the photoreceptor now can sense the light, which is the electromagnetic wave. So this is the skin. If you take anatomy, you have to learn all this. So our skin has actually three layers. The top layer is called epidermis. The second layer is not like this. The second layer should go from here to here. Yeah, it should go in here. This is called dermis. And then as soon as you see the subcutaneous fat, this part, we call it hypothalamus. Hypodermis. Hypodermis. Hypo means below or under. That means this part is under the dermis. Epi means above or on top. That means this part is on top of the dermis. So as soon as we see the fat, subcutaneous fat, then it is the hypodermis. So demonstration, I did the demonstration before the end of the class for receptive field. So the receptive field on the body trunk is called dermatome. The receptive field on the body is called dermatome. They are horizontal stripes. And remember, there's a clinical condition called shingle. Shingle is basically infection of the virus from chickenpox. Chickenpox virus. And then it will infect the nerve ending for the whole stripe because it infects this dermatome. And what else? Yeah, we also mentioned that the receptive field in our fingertips, in our neck, in our lips, in our tongue, they are very small. That makes those areas very sensitive. So the smaller the receptive field, the more sensitive that part of the body. The larger this receptive field, the less sensitive that part of the body. Vision. Human eyes are able to detect color. We are chromatic. We call it chromatic vision. Chromatic because we can detect color. We can see object from far away. We can also see object close to us. And we can detect a few photons. If the light is dim, we can still see things. We'll briefly talk about it, why. So this is the anatomy of the eyes. So I'll quickly go over its structure. Pupil is basically an empty hole that allows light to go in. Pupil is formed by iris. Iris, they are the color part of the eye. So if you have blue eyes, that means your iris is blue. For me, my eye is brown, so my iris is brown. Iris is the part that forms the pupil. It also adjusts the size of the pupil, meaning that you can adjust the amount of light that goes into the eyes. Lens is the part of the eyes that focuses, that bends the light so that the light can be focused on the retina. And then we have fluid in both, in between. This is called cornea. Cornea, they are made up of transparent cells. And this is the part that cornea transplant, and it is expensive to get a cornea transplant as well. We have fluid here between the cornea and the lens. And also we have fluid here between the lens and the retina. The fluid in those areas is important because they are here to maintain the appropriate pressure in the eyeball. If we have too much of the fluid and the pressure is too high, that will be called glaucoma. And then we have something called sclera. Sclera, they are the tough white part. of the eyeball. In Bio 3B lab, you should have a lab that allows you to dissect a cow eye. Then you will see all this structure. And then there's a pigmented layer. The pigmented layer is called tapetum lucidum. The pigmented layer, tapetum lucidum, is the part that causes, when if you have a dog or a cat, at night you can see that their eyes will glow, right? Why is that? Because their tapetum lucidum, this pigmented layer, is extremely reflective of the light. That will allow them to see in the dark easily. Why is that? Because when the light, retina is in front of the pigmented layer, the tapetum lucidum. So when the light hits the retina, then we can see the object. But if it is a very dim, let's say at night, so what happens is that when the light hits the retina, the tapetum lucidum can also reflect the light, so that the light will go back to hit the retina the second time. So if this pigmented layer, tapetum lucidum, is very reflective, it's very shiny in dogs and cats, then that means only a dim light can be reflected twice. Then in this case, the animal can see in the dark more efficiently than human being. For human being, our pigmented layer, the tapetum lucidum, is not that reflective. That's why we are not very good at seeing in the darkness. Retina, they have the photoreceptor that can detect light, and that is the firing of the photoreceptor that sends the action potential through this optic nerve here. When the optic nerve is exiting the eyeball, we call this part the blind spot, because in this part there's no photoreceptor here. So different function of the function of different part of the eye. Cornea allows the light to go into the eye. It also helps focusing of the light. Iris regulates the size of the pupil to adjust the amount of light going into our eyes. For example, in daytime, our pupil will be smaller because we have too much light. But in nighttime, our pupil will be larger to allow more light to go in. The lens changes shape and focuses the light by the retina, which is very important. If there's an issue with the lens, then we won't be able to see the light. The light won't be able to focus on the retina. Then we have to wear glasses. So animation near distance vision.
The lens focuses light on the retina by bending light rays, and it changes shape to adjust focus when you look at near or distant objects. When you look at a nearby object, muscles attached to the choroid contract, allowing ligaments attached to the lens to slacken. This reduces tension on the elastic lens, which becomes thicker and rounder, bending light rays more sharply into focus. This is called accommodation. When you look at a more distant object, the muscles attached to the choroid relax. This allows the ligaments to pull on the edges of the lens, flattening it. The flatter lens bends light less sharply, focusing light from the more distant object onto the retina.
So this is basically a summary of what we just saw on the video. For the near vision, how come we need to wear glasses? So when we, this is not, this is normal vision. Let's say when we are reading newspaper or reading a book, what happens is that the book or the newspaper is here. Then the muscle will be contracted. When the muscle contracted, that means the two muscles will get closer. And get closer, the fiber, the ligament here, the fiber here will be slackened, will be relaxed. When the fiber is relaxed in here, the lens is elastic tissues. the lens will allow to rebound back to its original shape, so that it becomes rounder, and then it can focus the proximal object onto the retina. On the other hand, when we are looking at the distant object, then the muscle will relax. When the muscle relaxes, they will pull apart. When they are pulling apart, then the ligament here holding the muscle and the lens will be pulled on. So the ligament will tighten. And because of this, it will pull the lens, so that when the lens is pulled, it will be thinner. When the lens is thinner, then you can focus the light from the distant object onto the retina. And there are two types of photoreceptor, cone and rod. So cone cell is for color vision. It's for chromatic vision, blue, green, or red. Rod cell is for achromatic or black and white vision. The reason is that cone cell, we have three types of cone cell. Each type of cone cell, one type of cone cell can detect blue light, another type can detect green light, and then the last type can detect red light. But we only have one type of rod cell. As you can see that the photoreceptor here, cone cell only has a few of this disc. Rod cell has a lot more disc. The disc in here, they are for detecting light. If you have more disc, that means it is more sensitive to light. Light will go through all the discs. So it is very similar to the chloroplast. Remember chloroplast? You have a granum and also you have thylakoid. So it is just like those. It is just like the thylakoid. You have a stack of the thylakoid here. Similarly, so when light goes through, if it is a very dim light, then you have a lot of this detecting this to detect the light. But for cone cell, it is for detecting the strong light. That's why you don't need to have that many discs. Rod cell, we use rod cell to see things in darkness. That's why we need more of this disc to detect weaker light. So rod cell and cone cell detect light using array of discs containing light-absorbing pigment, just like chloroplast. The thylakoid in the chloroplast convert the electromagnetic photon into electrical signal, which is action potential. So convert electromagnetic photon into action potential. And the other retinal neurons, okay, sorry, this should be noxious. So other retinal neurons. So other than photoreceptor, there are other neurons in the retina. They are for processing and integrating the action potential generated from the photoreceptor. And then eventually all these neurons, they will converge into forming an optic nerve that leaves the eyeball to go into the brain. Which part of the brain it will go to? Ultimately, it will go to the back of our head, which is called occipital lobe, to process the visual information. So this is what happened. The light, the lens, when it hit the photoreceptor, it actually hit the photoreceptor is actually facing the back of the eyeball. So all the photoreceptors are facing the back of the eyeball, meaning all the light, you have to go through all these processing cells in order to stimulate the photoreceptor. After the photoreceptor is being stimulated, then the action potential generated by the photoreceptor will go backward. And then all these will form the optic nerve to go to the brain. Evolution. Our eyes are not perfect, of course. There are many things we cannot see. But nonetheless, it is very good. So each eye has a single lens. And interestingly, our structure of the eyes is very, very similar to the eyes of squid. Squid, their eyes are highly evolved, just like human being. They can actually see things in the dark or in the deep ocean when it is dark. But as I said, both our eyes and the squid eyes are very similar, but we evolve independently. It's because one squid is like a squid is solar. Because we are different, squid is not a vertebrate, it's a very low, primitive animal. So our eyes originated from two different tissues. We have two different origins, but they have the same function. So because of that, what do we call this? Do we call this homologous? Do we call it analogous? Is this an analogous structure or homologous structure? Our eyes compared with squid's eyes? The answer to this question is that it is an example of analogous structure because we are from different origin. The eyes are from different tissue, but we develop it through natural selection to have the same structure, the same function. And is it an example of divergent or convergent evolution? Is it divergent evolution or convergent evolution? Since the eyes of human being and the eyes of squids, they are analogous, so because we have two different ancestors, they developed to the same eye, then we call this convergent. It is a convergent evolution. So blind spot, I told you that the location or the exit of the optic nerve has no photoreceptor. We call it blind spot. So theoretically, we cannot see anything, but somehow you may say, how come we can see everything here? The reason is that the so-called visual field from each eye, they overlap with each other. So the visual field from one eye fan out like this, the other eye fan out like this. So you can see that they overlap. The overlapping of the two visual fields cover the blind spot of each eye. So this is an interesting question. Would our eyes function better if the optic nerve didn't pass through the retina? Instead went behind the photoreceptor? Probably, because we would eliminate the blind spot. But that's okay, because we have two eyes. Each eye covers the blind spot of the other eye. And then, but the squid's eye has no blind spot. So when I show this picture to another schools, SMC actually, SMC, one student noticed something interesting and asked me that during the lecture. He asked me, what's the purpose of having so much, you see that this is optic nerve of human being, this is optic nerve of the squid. How come octopus, doesn't matter, octopus or squid, and how come the octopus eye has a lot more of the optic nerve than human being? So what's the purpose of this? And it is one of the best questions I have heard from different community colleges. The reason is that octopus, squid, they all live in a deep ocean. It is very dark in there. So because of that, there's not much light. By increasing the amount of nerve output from the eye, even if you only have 1 or 2 photons that can get on the retina, then it can effectively amplify the output from the eye to the brain. On the other hand, here we live on the land, so we have sunlight all the time. We don't need that much of the amplification of the photon, of the signal. That's why our optic nerve is a lot smaller. So if you have a piece of paper, if you put a dot and a cross on a piece of paper, and then you close one eye, you have to close one eye, and then orient that piece of paper in front of you, and then eventually you will see that one of them will disappear, and because that one of them will be landed on the blind spot. So how do we correct our vision problem? We have three different types: nearsightedness, farsightedness, and astigmatism. And then nearsightedness, we are able to look at, let's say we can read books, but we cannot see object farther away from us. Farsightedness is the opposite. We can see, let's say, the object farther away from us, but we cannot read the books close to us. That's why we always, in the supermarket or pharmacy, we have the reading glasses, is to correct this issue. Stigmatism. Stigmatism is a blurred vision because there's the lens or the cornea, they have a spoon shape, or the curvature of the cornea or the lens is not regularly, it's not evenly circular, it's not evenly spherical. So when you have distant object blurring, when you have a nearsightedness, then what happens is that you use a concave lens to correct the issue. When you have farsightedness, that means you cannot see the distant object. Farsightedness, when you cannot see a close object. What happens is that we wear the convex lens to correct it. So you need to know the different issue, their causes. It can be the eyeball is too large. This one can be eyeball is too short. And then what they can see, what they cannot see. And also you need to know what kind of lens they wear to correct the issue. So this picture, I can ask you several different types of questions. Vision problems and correction, and other than wearing